I'm a game changer. I'm a risk taker.
This is our presentation for the competition. Our team name is RoboCup. Team ID is SG8065. For our team, there's Brandon and me, Shixuan. We are students from Singapore Polytechnic. It is my first RoboCup competition and Brandon's 8th year in RoboCup. So for the exclusive summary, we are under the university category and the problems we investigate are how to let the robot car move directly towards the deposit box after fully loaded, how to get 2 sets of RGB, and lastly, how to get the robot car to collect RGB more efficiently. The method that we use is the 𝗂 algorithm, which I'll be sharing with you on the later part of the presentation. For our challenge mission is to collect as many points as possible within 6 minutes. And then we have divided the challenge into 3 mini tasks. Firstly is pathfind through the treasure zone. For pathfind through a 5 treasure zone, if there is no object loaded on the robot car, it will move to the 5 treasure zone to collect the RGB. Or when there's any missing RGB respectively, the robot car will move to the respective zone with that color, hence collecting it. When there is x and y coordinate for a super object, the x and y coordinate will be stored into variables, and the robot car will be using these stored values to move to the coordinate, thus picking up the super object. If the robot car is fully loaded, or there's only 35 seconds left, or when the robot car has a super object and there's only 36 seconds left, the robot car will move directly to the deposit box to deposit. And after breaking it down into these 3 mini tasks, we are able to achieve the challenge mission. So now I'll be sharing with you guys on AI algorithm. We have decided to use the 𝗂 algorithm, as the 𝗂 algorithm is one of the most successful pathfinding algorithm out there due to its optimal efficiency. A demo of how this 𝗂 algorithm works is being shown on the right side of the screen. So how does this 𝗂 algorithm works? It uses 3 variables, the ℎ_cost, 𝑔_cost, and 𝐹_cost. The ℎ_cost is the estimated movement cost from the node to the destination. On the other hand, the 𝑔_cost is the movement cost to move from the starting point to the target node. So in order to get the 𝐹_cost for each node, we would add both 𝑔 and ℎ_cost together. However, there are numerous ways to estimate the ℎ_cost, and the options we have are the Manhattan distance, diagonal distance, and Euclidean distance. Firstly, I'll start off with the Manhattan distance. The Manhattan distance is the sum of difference between the xy coordinate of the destination and current node with the formula as shown. This method is usually used when the robot car can only move in 4 directions, which means forward, backwards, left, and right. Next, the option we have is diagonal distance. The diagonal distance is the absolute difference between the coordinates where the coordinates are compared separately, hence the 2 lines of node. This method of calculation is usually used when the robot car can go in 8 directions, which is shown in the previous slide, plus the 4 diagonal directions in. The last option we have is the Euclidean distance, which is the actual distance between the node and destination. This is usually derived using the Pythagoras theorem and hence the formula. This method is usually used when the robot car can move at all angles. So, to refresh your mind, there are 3 main methods in calculating the h-cost: Manhattan, diagonal, and Euclidean. The Manhattan distance is used when the robot has access to 4 directions, where the diagonal distance is used when the robot has access to 8 directions. Finally, the Euclidean distance is used when there is access to all angles. Since the robot car has access to all angles in CoSpace Rescue, we have chosen to use the Euclidean distance for our pathfinding program. Now, I'll be sharing on the debugging. So after we have done out our program, we run our program using the CoSpace Rescue and realize that from time to time, the car will start spinning at one point for a while before continue moving forward. After looking through our program and running the program a few more times, we realize that the reason why the car spins is due to the distance. If the distance is too great for the algorithm to calculate, it will cause the car to spin. Thus, we solve this issue by limiting the distance the algorithm can calculate. In conclusion, 𝗖𝗄𝙗 has helped us in solving the problems we investigate, as it helps to calculate the best path, thus allowing the car to move by the more efficient path when the car is going from one point to another. Other than that, 𝗖𝗄𝙗 algorithm is able to detect obstacles, and this allowed the car to avoid all the obstacles in the map. Through using the CoSpaceRobot, I've learned how to build up a simple program to make the robotic car move, turn, collect objects, and avoiding walls by using the C language or the Python. I've also gained more knowledge in each component of the car and many new advanced ways to program the car. And what I've gained through this challenge is that I understand how important and helpful it is to understand the map and break down the map into different parts, and it may help to do up the program more easily. And through this challenge, I have the chance to explore and learn more new advanced ways to program the car in order to get as much point as possible within the 16 bits. Thank you for listening to our presentation.